For today's lesson, kind of like last week when we learned about points, lines, and planes, we're going to be talking about angles, and it's a very heavy vocabulary day. So in these notes, I'm going to go through all of these terms and more to talk about how we build and measure and work with angles. And there's even a lot more angle vocabulary on top of this that we'll learn later when we get into relationships between angles. But today we're just talking about forming individual single angles. Let's start off with rays. Rays are important because we use them to build angles. A ray is a geometric object that's kind of similar to a line segment or a line. For example, I could make a ray called AB, named by 2 points, but instead of having a flat line or a line with 2 arrows, it has 1 arrow on top. So this is notation for what a ray would look like. To see what the actual geometric object looks like, this symbol tells us it starts from A, because that's this end, and it goes toward B with an arrow, meaning it goes on forever in that direction. So if I have this ray from A through B, and then it goes on in the direction of B forever and ever. So it has to be named in that order. The arrow here in the notation always points to the right, so the first thing we list has to be the end point, and the second one has to be the direction where it continues on. So I can't call this ray BA, that would be a different object. That would start from B and go toward A forever. Let me draw that one in a different color. So if I did BA, that would start from B and go toward A. And we also can't reverse this arrow, so we can't say BA with a backwards arrow. That's not how we name rays. We have to have the arrow going left to right. So that's how we name a ray, and ray sounds kind of like sun rays, so I think of it as being like if you have the sun, it shoots out a bunch of sun rays, where the sun is the end point and the ray goes out forever in one direction. So the light just keeps traveling straight away from the sun in those rays. Okay, so next thing, opposite rays. So if we have more than 2 points that are collinear, so let me go back to this color. If I have points F, G, and H, which are collinear, meaning they sit together on a line, so something like that, I can create a line using what we call a pair of opposite rays. So if you think about a ray starting from G, let's draw this one in green. Starting from G, going toward H, I could name that ray GH, like that. And then if I make a ray starting from G, going the opposite direction, starting from G and going through F, those 2 rays together, called opposite rays, form a line. So anytime you have 2 collinear rays that start from the same endpoint and go opposite directions, we end up with a line. So if you ever see like a line and it says name a pair of opposite rays, that's what it's looking for, is pick an endpoint between 2 others and then shoot off a ray one way and the other way. So those are rays, and the reason those are important is because an angle is basically a corner or a space between 2 rays. It can also be between like line segments or lines, but to make the most basic angle object, we'd have an end point with a ray going one way, and then we saw if a ray goes exactly opposite, it makes a straight line. So here we're going to shoot this ray off at a different direction, and what we end up with here is some angle or a corner in between those 2 rays. So we call these 2 rays arms. So that's our first word here. We can call them the arms of the angle, because it's like 2 arms reaching out making an angle. We can also call them sides. And if we do, there is an initial side and a terminal side. Remember that we measure our angles counterclockwise, so this side here would be where the angle starts. We'd call that the initial side. And then the angle goes around counterclockwise to reach this ray, which would be the terminal side. Terminal is where something ends. Kind of like a train terminal or a bus terminal is where an end point of a line. Okay, next thing, angle. So the angle itself is basically how open this space is. It's a measure of how big the corner is between these two rays. Vertex, you're familiar with being like the edges or the corners of a shape. So these are vertices. And just like them, an angle always has a vertex, which is going to be basically if you follow the two rays to where they meet, or you could think of it as where they're starting from and coming out of, that's going to be the vertex. Vert is a prefix meaning turning. So this is literally a turning point. So if we kind of followed along one ray, we would hit a turning point and then go that way and follow the other ray. Just like on a shape, a vertex is where if we're following one side, then we turn at the vertex and head toward the next side. Then we turn and we turn. So vertex literally just means turning point. Angles can be named in a few ways. So let's draw a new angle here. And this is actually like identifying the angle, not types of angles, like acute and obtuse. We'll get to that next. Those aren't the names we're talking about. We're talking about how to identify that we're talking about this angle right here versus some other angle. So for example, if I continued and made these lines instead of rays, I'm going to have several angles here. And like I said, there's relationships between those that we'll talk about later. So you may remember like adjacent angles or vertical angles. We'll get to those in a later lesson. But to identify that we're talking about this one, there's a couple of ways. We can name it directly, so we could call it like angle 1, and then that would mean we're talking about this one. We don't just call it 1 though, like a point. We refer to it with the angle symbol and then a 1. So this is different than a less than. Less than kind of is like a 45-degree symbol. This one swoops down at an angle and then comes flat across the bottom. So it's kind of like that more than a less than. So angle 1, we can name the angle directly like that. We can also use points. So if I had point A, B, C, D, and we'll call the vertex here E, I can name an angle by 3 points that trace the angle if you follow along them as you name them. So angle here, I could name this A, E, B, because as I draw from A to E over to B, I've just basically sliced out this corner where this angle is. So I could call that angle AEB. I could also call it angle BEA if I traced the other way. But notice that the vertex will always be the middle letter because we have to go through it and turn and go toward the other ray. If I wanted to name other angles here, this one down here, I could name DEC or CED. This one would be DEA for the top left angle or AED. So hopefully that's clear. You just basically trace between the 3 points. Don't close it off and make a triangle. We're just tracing from C to E to B, and that makes this angle right here. How else can we name? That's pretty much how we name. There is a special case if there's not multiple angles at a vertex. So if I have something like this, and this is A, B, C, we just talked about I could name this angle BAC or CAB. But if there's only one angle at a vertex, I can also just call this one angle A, because it's obvious there's only one angle I could be talking about. I can't do that up here because angle E could be referring to angle 1, angle 2, angle 3, or angle 4, because they're all meeting at the vertex E. So I can't use this notation for a case like this. I can only use it for a case that has a single angle at my vertex. All right, so that's all of what angles are. Hopefully most of that is familiar. That should all be generally stuff you've seen in earlier math. So hopefully not new stuff there. Some new things we're going to do with angles, though, is we're going to measure them. And you've looked at angles before, I'm sure, in terms of a number of degrees. So if we have an angle like this, where one ray is vertical and one is horizontal, I'm sure you know that we put this symbol in the corner and say that that is 90 degrees is the measurement of that angle. And you've primarily worked in rotations that we did this year and in other classes with increments of 90 degrees because that goes from horizontal to vertical, and that's a pretty easy relationship. But this year we want to be able to work with any angles. So we can make an angle here, and if those lines were straighter, I could measure them. I have a protractor. So protractor is a tool that we use to measure angles. This is kind of a weird one. A more normal protractor is like a half circle, but what it has in common is there's a point at the center. Usually on a physical protractor, that's a little hole in the middle. We can place that over a vertex, and then we align the protractor so that the zero angle, how do I rotate you? I've never used the protractor in this program before, so interesting to do it live. I don't see a way to rotate it, but the idea is you put the center point of the protractor on your vertex, and then you align the 0 degree line with one of your rays. Then, if you look at where the other ray meets the edge, normally also a protractor has measurements to where you can read the number of degrees, then you can measure the angle and see how big the angle is. Now, how do you go away? Okay, so there's a failure for using that protractor. But the idea is we can measure how open this angle is and say this was 47 degrees or however big it was. And we measure angles using this protractor, and we typically have units of degrees. I'm sure you know that in a circle, if we go all the way around a circle, we travel 360 degrees. So an angle is just a fraction of that. So if I think about like a pie, and I cut out a slice of the pie, then that slice has a certain angle. And if I sliced up all the slices, all those angles have to add up to 360 degrees because they make a full circle. So that's a useful tool for estimating how big angles are. We know what 360 looks like. We know what 90 looks like. We kind of know 45 is like half of 90. So we can kind of visually estimate about how much angles are and then use a protractor to measure them exactly. So throughout geometry, we're going to measure degrees, angles in degrees, but there are two ways of measuring angles. Degrees is the one that we typically use in lower level math, and then in higher level math and science, we usually switch to one called radians. So it's not too important to understand radians at this point, but I do want to mention them. So basically, we have a circle, and we said we could divide it into 360 tiny slices that would make up 360 degrees. But if you recall, we have some formulas for circles, and they look like things like perimeter or circumference is 2 times pi times the radius, and area is pi times the radius squared. So circles have this idea of pi kind of baked into them because they just follow pi. So what we can do is divide the angle into increments of pi instead of increments of 1 over 360, which is kind of arbitrary and based on ancient systems. So what we can do is instead of saying this is 360 degrees, we can say that it is 2 pi radians. So a circle can be measured in radians or degrees. So if I went 1/4 of a circle, we usually call that 90 degrees, but we could also divide that 2 pi into fourths and say that this is pi over 2 radians to make up 90 degrees. So the main reason I want to mention this here is that when you're using calculators, they typically have a function to switch between radians and degrees. Like on Google Calculator or on our TI calculators, it'll say rad or deg, R-A-D or D-E-G. So when you're using a calculator, make sure that if it says RAD, we switch it to the mode where it says degrees, because we want to measure everything in degrees for now, because even if you understand radians, we're not really using those quite yet. Those come later. Okay, last thing was notation. So I kind of just talked about notation. Degrees have this degree symbol. Radians actually don't have any unit specified. It's a unitless quantity. And then to write the size of an angle, we don't write like angle A equals 47 degrees, because the angle is a geometric object, not just the size of it. So we don't just say that. Remember how with segments, we said the length of AB was 4 inches, or the, we said the length. So it was different than the name of segment AB, right? That's the point I was trying to make. So if we have angle ABC, to get the measurement of the angle, kind of like here we just put the 2 letters, we can't just put 3 letters because that's the name of a plane. So we put a little m and then angle ABC, and we say that equals 47 degrees. So our notation for how to write the measure of an angle is just to put a little lowercase m in front of the name of the angle, and then we know that we're getting the measurement of it, not referring to the angle, like the object. Okay, next thing, angle types. This is stuff that you've learned before for the most part. You've learned about acute and obtuse angles. So you know that an angle smaller than 90 degrees, we call this acute. An angle greater than 90 degrees, we call this obtuse. And an angle exactly 90 degrees, which this is not, an angle exactly 90 degrees, we call a right angle. So those are 3 terms that you should already be familiar with, hopefully. 2 new terms that we're going to add is straight angle, which I think is a pretty dumb name, is basically if we have a line, then we could refer to this as a straight angle, meaning that it is exactly 180 degrees because it's half of a full circle, right? If I drew my angle on this side or my angle on this side, together they make the full 360. So a straight angle is just a line. But if you see the term straight angle, you need to know that that's a line. The other one that's new is reflex angle. So reflex angle is like the opposite angle. And as an example, we have this acute angle, but we could also measure, so that would be, this is the initial side and the terminal side, right? I'm measuring from here to here, and I make an acute angle. But what if I reverse that and I make the starting point the left ray, and I'm going to circle around until I get to the ray on the right? Then instead of an acute angle, I would go all the way around here as this gigantic obtuse angle, and we call that a reflex angle. So actually obtuse probably has to be less than 180. So the idea here is this is the angle that is kind of the supplementary. So supplementary is a word hopefully you know. Supplementary angle. So the reflex angle is supplementary. No, supplementary is 180. It's a whole other thing, sorry. So you learned complementary and supplementary before. So complementary means 2 angles add to 90. Supplementary meant 2 angles add to 180 degrees. And then this new idea of a reflex angle is the angle that with your angle adds up to a full 360. So it basically completes the circle. And you can have a reflex angle for any angle. So if we had this obtuse angle, the reflex angle would be here, and together they'd add up to 360. So if our obtuse angle was 120, our reflex angle would be 240. If our acute angle here was 30, then our reflex angle would be 330. Okay, so that's our vocabulary for angle types. We had 2 new ones, which were straight angle, which is a straight line, and reflex angle, which means we are completing the 360 rotation. So you could think of it as 360 minus the measure of the angle that you're working with. Yeah. All right, last notes for today. Angle bisectors. We talked about segment bisectors just recently. Angle bisector is the exact same idea. So if you recall, a segment bisector, we said, was anything that cuts a line segment into two equal pieces. So we split it right down the midpoint, and we end up with these little two dashes that tell us those two parts are equal in length. Also meaning they are congruent line segments. So we had congruence here. So with an angle, if I have this angle, I can split that angle exactly in half. We can have another ray that cuts exactly halfway through the angle, and we end up with these two equal angles, and we use this little arc symbol, like a single one, to show that those two are equal. If we had another equal one, we could use a double arc to show those two are equal. So what we end up with is, if we had ABC as our initial angle, and we split it with ray BD, then we end up with angle ABD, so that's the upper angle, would be congruent to angle DBC, which is the one on the right. So in total, these two together add up to the original ABC. So we also have the idea that we had with segments where we can add them. So the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC, the one we started with. So there's some practice to do for today. Today was a lot of vocabulary, a lot of new concepts, and a lot of revisited concepts from earlier years.